Okay, so today we're doing integration, pure maths year 2. It has integrating to find the areas under the curve, the definite integration. So before I go ahead, let's understand what is integration. From understanding what is integrating, integration is just the opposite of differentiation. See, I have a function and my function is y. Okay, if I am to remove the derivative of this function, what do? I remove the derivative of x raised to n. It would be nx n minus 1. That means I would multiply with the power. So if it's 5x cubed, the power is 3. I multiply with the power and reduce the power by 1. So it becomes 5x squared. So this is what is, sorry, it becomes 15x squared. So this is derivative. You multiply by the power and reduce the power by 1. Derivative is going to give me my gradient function. But now if I want to do integration, integration normally tells me my area under the curve. Okay, so it is just the opposite of the gradient function. So gradient function gives me the equation of the curve and integration gives me the area under the curve. Suppose if this is my curve and I want to find area, the integration would give it to me. Okay, now this was my y. I got the gradient function, I did the derivative and got my dy by dx. Now if I want to integrate it, I will increase the power by 1 and divide by the new power. Okay, so if I am increasing the power by 1, so the x would become 3. 15 is there, and I'm dividing by the new power. So it becomes 3 ones and 3 fives. So I come back to the function again. So from the gradient, if I want to go to the function, or I would say from my dy by dx, if I want to go to my y, I would integrate it. But the only issue over here is, say for example, you have your dy by dx as 3x square. Okay, dy by dx is 3x square. That means you have your gradient as 3x square. You want to arrive at y, or you want to get the function, so you're going to do integration. You will add the power, okay, and you divide by the new power. So this is going to become x cubed. But the issue is that when I do derivative of x cubed, I am going to get 3x squared. But even the derivative of x cubed plus 2 is still going to give me 3x squared. Even the derivative of x cubed plus 4 is still going to give me 3x squared. So we really do not know that when I am going from the x cube, okay, from the 3x squared to the function y, from the gradient to the function y, what is the constant? Was there any constant? Okay, was there any constant 2, 4, 5, 6? Was there any constant or was there no constant? I really do not know. So, when I am going from the derivative to the function, I am always going to add a c. So, from 3x squared, when I'm going to find y, I'll add the power divided by the new power, and I'm going to add c. So, the new function would be x cubed plus c. Let's take this with an example. I have to find y. Okay, so y is equal to, I have 4 over here, add power, add 1 to the power, divide by the new power. So it is going to become x4 plus c. You could try these two for yourself. So let's do this alongside. I have the gradient as x5. I want to find the function. So my y would be add 1 to the power, divide by the new power, plus the c. Do not forget to add this. So it would be 1 by 6 x6 plus c. Again over here, I have the gradient and I want to go to the function. I will add 1 to the power. Okay, so this 1 by 2, it would become, I would add 1 to the power. So this is going to become 3 by 2. I would divide it by the power, new power, plus c. I always use this form rather than writing down because it becomes easier for me. You know, when you divide by a fraction, it is going to be multiplication by the reciprocal. So it becomes 2x raised to 3 by 2 plus c. Okay, do not forget to add the constant whenever you're going from the derivative, from the gradient to the function, and the function gives you the area under the curve. Whenever you're doing a derivative, you're finding the derivative, or you are finding the integration. Okay, you're finding the integration of the gradient. You're finding the integration of the gradient. You're finding the integration of your derivative dy by dx. Your rule number 1 is that whatever you are going to do with whatever equation you're going to deal with, you always convert it into the indices form, for which I always ask my students to have certain forms of root x always handy with you. So when I say it's root x, what does it mean? It means x raised to half. If it's cube root of x, it means x raised to 1 by 3. If it's fourth root of x, what does it mean? It means x raised to 1 by 4. If it's nth root of x, it is x raised to 1 by n. Okay, if I have my x in the fractional form, I will first bring it to the indices form and then I solve ahead. If I have 1 over root x, it means x raised to minus half. If I have 1 over cube root of x, it is x raised to minus 1 by 3. If I have 1 over x raised to 2 by 3, so it's going to be x raised to minus 2 by 3. Some combined expressions which you should know. X root x is x raised to 3 by 2. How do I know this? X is half plus half. Okay, x raised to 1 is x raised to half plus half, or I would say it is x raised to half into, not into half, it is half plus half, so it gives me x raised to 1. Okay, so x into root x would give you x 3 by 2. X square root x is going to give you x 5 by 2. And 1 by x root x is going to give you x minus 3 by 2. So x root x gives you x raised to 3 by 2. And 1 by x root x gives you x raised to minus 3 by 2. Okay. Also, you keep this in mind that x over root x is x raised to half. So these are some expressions which you should know. So here is one for you to solve. Okay. You know that when I have my dy by dx, I say this is my dx and this becomes dy by dx. I get the gradient, that is 10x. When I do anti-differentiation, okay, That means from the 10x, I'm trying to arrive at my function. So when I do anti-differentiation, I add 1 to the power. And after I add 1 to the power, what do? I divide it with the new index. So this is called anti-differentiation. Let's try and strengthen our skills of difference integration. Okay, you differentiate, you find the gradient. When you do integration, you get your original function, but do not forget to have the constant in place. Okay, now this is called definite integration. So y is your function, this is your dy by dx. When you integrate your dy by dx, okay, you will get the y. So the notation stands for, this is integration. You integrate your gradient, okay, this expression with respect to x dx means, so you're going to get y. This is called an indefinite integration because there are no limits over here. Okay, so it's indefinite integration because exact expression is not known to us and we add a plus c. So now over here, when they've asked you to determine the original function, how do you go about with it? For the first one, what will you write? They want the original function, so that means I'm integrating 2x plus 7 with respect to x, add 1 to the power, divide by the new power, okay, plus c, y is equal to, so what answer I'll get is 1 over 4 x8 plus c. Do not forget this. Let's do the next one. B1, I'm integrating x plus c. Please note my dy by dx is equal to f dash x. That is the gradient. X plus 3 with respect to x. So this becomes y. But since it is f dash x, I can use f of x is equal to, add 1 to the power divided by the new power plus 3. I add 1 to the power, that means I add an x and I get plus c. First, you always have to check whether your given equation is in the indices form. Okay, it's in the index form. If it's not in the index form, always get it to the index form. Now we are doing the C part. That means we're integrating with respect to x. So if I'm getting y, add 1 to the power divided by the new power. Again, add 1 to the power divided by the new power minus x divided by 1, and I will do plus c. Okay, do not forget to put the plus c. So this becomes 1 by 16x8 minus 1 by 3x cubed minus x plus c. This is my original function. Okay, so always remember the meaning of this. This means differentiate with respect to x, your y. This becomes the differentiated thing, that is your dy by dx, or I would say it's your gradient. When you take the gradient, you integrate it with respect to x, you are going to get your original function, but it is always, you have to add c because you do not know whether your original expression had a plus c or it did not have the plus c. Okay, now we'll do the next one. Try it. always ensure that your term is in the power, is in the index form. So root x, when you are going to integrate, you will write x raised to 1 by 2. This is x cube. When you're going to integrate it, it's going to become x raised to minus 3. Okay, this is root x. When you're going to integrate it, it's going to become x raised to minus half, and this is going to become x raised to minus 2. This is already in the index form, so you need not worry. So, I hope you've done this. Let's quickly discuss this part. Okay, I'm only discussing, then you can see your answer. Root x, first you will ensure that it is in the indices form. Okay, so I'm going to integrate. I'll convert it into indices form. Now I'm ready to integrate. Add 1 to the power. So it's 1 by 3. I'm adding 1. It becomes 4 by 3. Okay, divided by the new index. When I'm going to divide it by a fraction, that means I'm going to multiply it with the reciprocal of it, plus c. So this becomes 3 by 4, x raised to 4 by 3 plus c. Let's do the next one. We know that x root x is what? First thing to check is always if my equation is in the index form, sorry. So it's 5, x into x root x is 3 by 2. I've got this in the index form, plus 3. Now I'm going to differentiate with respect to x. 5 is already there. Add 1 to the power. So it becomes x raised to 5 by 2. Divided by the new power. So I'm going to multiply with the reciprocal of it. Add 1 to the power divided by the new power plus c. So this becomes 2 x raised to 5 by 2 plus 3x plus c. Over here, first I have to make it into the index form. So it becomes 4 x raised to minus 3 dx. Add 1 to the power divided by the new power plus c. Okay, add 1 to the power divided by the new power plus c. Check what it's going to give you. It's going to give you x raised to, okay, I'm adding 1 to the power, so it becomes 2. Sorry, my bad. It's 1 to 1s and 2 2s. It's going to become 2 x raised to minus 2 plus c. The last one, it's already in the index form. Add 1 to the power. So this is going to become x 7 by 5 divided by the new power. That means multiply by the reciprocal of this plus next one 3x, add 1 to the power. This is going to become 3 by 5, multiply, divide by the new power. So I'll multiply by the reciprocal of this plus c. Indefinite integration, because I do not know that when I was finding the derivative, whether the constant went away or there was no constant. So I will always add this plus c. So this becomes 30 by 7 x raised to 7 over 5 plus 5 x raised to 3 over 5 plus c. Okay. Another form of integration is that if you have something in brackets, okay, Before you do the integration, expand the brackets and get it in the most simplified form. After you get it in the simplified form, you can find the integration. Similarly, if I have to integrate this, okay, I have two brackets. The first thing that I would do is get it in the index form. Okay, if I'm going to get this in the index form, so it's becoming integration of 1 minus x raised to half and 2 minus x raised to 1 by 3 dx. After I do this, expand the brackets and then get the integration of it. Okay, this is going to help you solve it better. The solutions are down. You can try it yourself and then come back to me if you have any doubts.